So for this problem, to find the third term and the eighth term in the geometric sequence, so given the sixth term and the 11th term, so take note that from this given, there are numbers between a sub 3 and a sub 6. So that's a sub 4 and a sub 5. And there is number between a sub 6 and a sub 8. So that's a sub 7. And there are numbers between a sub 8 and a sub 11. So that's a sub 9 and a sub 10. So since from this given, there is no first term or a sub 1, so therefore, we're going to use this formula to solve for this problem. So we have a sub n equals a sub m times the common ratio to the power n minus m. So since a sub n is the last term, so from this given, this a sub 11 is a sub n. This is the last term. So first, we need to find the common ratio using this a sub 6 as a sub m. So to find now the common ratio, substitute now all the values to this formula. So for a sub n, that's 128, then equals a sub m negative 4 times the common ratio for n, since a sub n is equal to a sub 11, so therefore n is equal to 11, then minus 4m, since a sub m is equal to a sub 6, so therefore m is equal to 6. Then to simplify, so we need to divide both sides by this negative 4. Divide by negative 4 to cancel this negative 4. So we have 128 divided by negative 4. So 128 divided by negative 4 equals, so that's negative 32. So this is negative 32, then equals the common ratio to the power 11 minus 6. So this is 5. Then to solve for the common ratio, since the exponent is 5, so therefore we need to take the fifth root for both sides. So cancel. So therefore R, or the common ratio, equals, and for the fifth root of this negative 32, so we can use calculator to find the fifth root of this negative 32. So we have 5, that's the root, then shift K, this function, then we have negative 32, close parenthesis, equals, so the fifth root of negative 32 is negative 2. So therefore the common ratio is negative 2. Then this time we can find now the third term. So to solve for the third term, then the same formula to solve for the third term, but this time a sub 3 becomes a sub m, and still a sub 11 is a sub n because this is the last term. So apply now this formula, so we have a sub n, so that's 128, then equals for a sub m, that's a sub 3, then times the computed common ratio, that's negative 2 to the power n. So n is equal to 11, then minus 4m. Since a sub m is a sub 3, so therefore m is equal to 3. Then to simplify, so we have 128 equals a sub 3 times negative 2. Then to the power 11 minus 3. So this is 8. Then to simplify, so we have 128 equals a sub 3 times. So for this negative 2 to the power 8. So since the base is negative 2, so we need to put inside the parentheses, then negative 2 to the power 8. So this is equal to 256. So we have 256. Then to solve for a sub 3, divide both sides by 256. So a sub 3 equals, so this 128 over 256, so we need to reduce. So using this function, and we have 128 then over 256, so that's equal to 1 over 2. So therefore the third term is 1 over 2. Then to find the eighth term, so to solve for the eighth term, so again the same formula, but this time eighth term becomes a sub m, and a sub n is always a sub 11. So using now this formula, so a sub n, that's 128, then equals a sub m, that's a sub 8 times the common ratio, that's negative 2 to the power n. So n is 11, then minus 4m, that's equal to 8. Then to simplify, so 128 equals a sub 8, then times negative 2 to the power 3, so that's 11 minus 8, that's 3. Then we have 128 equals a sub 8, and this negative 2 to the power 3. So we need to put inside the parentheses, then negative 2 to the power 3. So that's negative 8. So this is negative 8. Then to solve for a sub 8, divide both sides by negative 8. So therefore the eighth term equals to this 128 divided by negative 8. So we have 128 divided by negative 8 equals negative 16. So the eighth term is equal to negative 16.